Linear differential equations. Linear differential equation of the form dy by dx plus py is equal to q. Here p and q are functions of x, is called first order linear differential equation. Now here dependent variable is which one? Dependent variable is y. So dependent variable and its derivatives occur only in the first degree and are not multiplied together. Okay, so remember this. Okay, let's see how to solve such equations. So we are given dy by dx plus py is equal to q. Now let's multiply this with e to the power of integral of p dx. So dy by dx plus py times e to the power of integral of p dx is equal to q times e to the power of integral of p dx. Let's distribute this. Dy by dx times e to the power of integral of p dx plus py times e to the power of integral of p dx is equal to q times e to the power of integral of p dx. Now we integrate both this, all the terms. Now when we integrate, what happens? Now observe this carefully. This entire thing is nothing but the differential of, so when we differentiate this term y times e to the power of p dx, we get these two terms is equal to integral of q times e to the power of p dx integral. Now if you want to verify whether this actually happens or not, just do it, differentiate this. So y remains as it is and we differentiate e to the power of, so e to the power of remains as it is. Now we have to take care of this. So when we differentiate the integral, it becomes p dx plus, now what do? We differentiate y. So we get dy by dx times e to the power of p dx remains as it is. So here you see dy by dx times e to the power of integral of p dx plus integral of py e to the power of integral of p dx. When we integrate this, so let's put the constant of integration. This and this gets cancelled. We are left with y times e to the power of integral of p dx is equal to integral of q times e to the power of integral of p dx plus c. Here e to the power of integral of p dx is called the integrating factor, or if in short. Okay, now let's see how this works. Let's solve one or two problems. Let's say the equation given is x dy by dx minus 2y is equal to 2x. Okay, so let's say dy by dx is equal to 2x plus 2y by x, which is equal to 2x by x plus 2y by x. X gets cancelled. So dy by dx minus 2y by x is equal to 2. So here p is equal to minus 2 by x and q is equal to 2. Okay. Remember, e to the power of integral of p dx is the integrating factor. So we have to evaluate that. So first let's evaluate integral of p dx is equal to, now p is minus 2 by x dx. We can take out minus out, 2 by x dx. We can actually take out 1 by x and minus 2 out. So this is nothing but minus 2 log x, which minus 2 can be taken up, and this becomes 1 by log x square. Now e to the power of integral of p dx is equal to e to the power of log of 1 by x square. So this log and e gets cancelled. So the integrating factor becomes 1 by x square. So therefore, remember our solution, y times e to the power of integral of p dx is equal to integral of q times e to the power of integral of p dx plus c. Now we do the necessary substitutions. Y times 1 by x square is equal to integral of, now q is what? Is 2. So 2 times e to the power of integral of p dx plus c. Okay, y by x square is equal to 2 times, actually this also we can do the substitution, 1 by x square. So this becomes 1 by x square plus c dx. Don't forget the dx. Okay, so this becomes 2 and this is x to the power of minus 2 dx plus c. And this will be minus 1 by x, right? When we differentiate this, we get minus times minus plus. So this actually becomes minus x minus 1. So when we differentiate it, plus 1 x to the power of minus 2, which is nothing but 1 by x square. So this is 2 times minus 1 by x plus c. Okay, so y by x square is equal to minus 2 by x plus c. Y is equal to minus 2 times x square by x plus c x square. So the solution is let's put the positive one first, cx square minus 2x. Yes, it can be tricky a little bit sometimes. So take it step by step by step. So the first step is what? Rewrite the statement, problem statement in this term, in this form. So you will get p and q. Then evaluate the integrating factor. So you get this. Then this is like your standard formula. You plug in the various values and then just keep simplifying. Okay, let's do one more. Okay, let's say sin x cos x dy by dx is equal to y plus sin x. Now dy by dx, let's take y plus sin x by cos x to the other side. So this becomes sin x cos x. Let's split it. So y by sin x cos x plus sin x by sin x cos x. So these two get cancelled. Let's rewrite this in the form that we require. minus y by sine x cos x is equal to 1 by cos x. Yes, now this can be written as sec x. Okay, now we have to figure out the integral of the integrating factor. So p dx is equal to, now here p is what? P is equal to minus 1 by sine x cos x, and q is what? Is sec x. So this becomes minus 1 by sine x cos x dx. Okay, this minus can come out. Now how do we integrate this? If we can come out with or convert this into some kind of a standard one, and one of the standard ones which I remember is sec square x by tan x, right? Because then it becomes log of tan x, right? So log of tan x will be 1 by tan x times differential of tan x, so which is sec square x. Yes. So how do I convert this into sec square x by tan x? How I do that? First of all, let's say 1 by sine x cos x. 1 by cos x is sec x, right? So 1 sec x we have. Now tan x we can get by dividing both numerator and denominator by, so denominator becomes tan x. So sec x by, now denominator if we divide it by cos x we get tan x. So we have to divide the numerator also by cos x. So 1 by cos x is what? Sec x. So square x. This is nothing but tan x. So which means minus integral of, we can rewrite this as sec square x by tan x dx, which is equal to minus log of tan x. Okay, now this is p dx. Now let's take it e to the power of. So when we do that, what happens? Since the power is negative, the whole thing goes down, right? So 1 by e to the power of log of tan x. Okay, and here e and log get cancelled, so we are left with 1 by tan x, which is nothing but cot x. So our integrating factor is cot x. Once we have done that, just remember the formula of the equation of the solution. The integral of q times e to the power of p dx plus c. Now do the substitutions. Y times this is cot x is equal to integral of q is what? Q is sec x times cot x dx plus c, which is equal to, now let's rewrite it in terms of sine and cos. So 1 by cos x times cos x by sine x dx plus c. This and this gets cancelled, and we are left with cosec x dx plus c, and the integral of cosec x is log of cosec x minus cot x plus c. So that is the solution for this differential equation. This is the general solution because of this. Okay, anyhow, so here the main thing you have to remember is the integrating factor, and the other is this equation, and being able to figure out p and q. Okay, that's enough. Bye for now.